Alright, so this is just a brief overview of Chapter 7 before we get into the practice test. There's 8 sections, and the first one's on graphing exponentials, second one's solving. The next 2, 3, and 4 on logarithms, how to graph them and how to solve them. 5 is on the properties of logarithms, 6 is on logarithms with base 10, that's what's called a common log. And then 7 is on base e, so the natural log. And then finally 7, 8, you have those word problems where we talk about how to apply them to different scenarios. Okay, so we'll just go through the practice tests. First one says sketch a graph. So let's pull up a graph right here so we have one. And the easiest way to sketch these would be to make a table of values, which is what we normally do. So this, by the way, this is going to take the graph of y equals 2 to the x, that's the parent function, and it's going to move it to the right one, because add to x, go left, that's subtracting from x, so we're going right. And then it's going to move it up one. So let's just fill in this table of values. We always want to start the table of values by finding something that makes this part 0. And if you look at that, x equals 1 would make that 0. So 2 to the 1 minus 1 would be 2 to the 0. 2 to the 0 is 1, plus 1 would be 2. So the point 1 comma 2 is going to be on that graph. So there's our first point. Then we'll pick a couple numbers bigger and a couple numbers smaller. So this one is going to be 2 to the 0 minus 1 plus 1. That's 2 to the negative 1, which is the same as 1/2 plus 1, and that's 1.5. So the point 0 comma 1.5 is going to be on this graph. So right about there. Then this one is going to be 2 to the negative 1 minus 1. That's 2 to the negative 2, which is 1 over 2 to the positive 2, or 1/4 plus 1. That would be 1.25. Sorry, that's supposed to be a negative 1. 1.25, so negative 1, 1.25 puts us about right here, and that's going to be like the asymptote. It's going to level off. Instead of leveling off at 0, it's going to level off at 1 because of this right here. That's the moving up 1 part. And then for the second part, for when y equals 2, so 2 to the 2 minus 1 is 2 to the 1. That's a plus 1 right there. 2 to the 1 plus 1 would be 3, so the point 2 comma 3 is on this graph, so right here. And then we'll just get one more point for accuracy. 2 to the 3 minus 1 is 2 to the 2 plus 1, and that equals 5. So we're going to have the point 3 comma 5, which will put us right here, and you can see the graph will look like that. It's been shifted to the right 1 and up 1. You can see the up 1 part, and the right 1 part, this number right here would normally be shifted over to right there, so it's been shifted right 1. Alright, solving exponential equations. So the easiest way to do these is we want these numbers to be of the same base. So we know that we're probably going to have a base of 4, 4 to the 2n, and then 1 over 64 is like 64 to the negative 1. And then how can I make 64 into a power of 4? Well, 64 is 4 to the third power, and it's still being raised to the negative 1. So we need to multiply those two exponents. 3 times negative 1 is negative 3. And if 4 to the 2n equals 4 to the negative 3, that means 2n must be equal to negative 3. It's the only way to make those equal, and n would be negative 3 over 2 would be our answer. Alright, this one right here, we want, again, the same base, so the base would have to be 2. 8 is the same as 2 to the third power, and we still have that negative x right there. Okay, so that must mean that when these get multiplied, you get 2 to the negative 3x equals 2 to the 5th. That must mean that negative 3x is equivalent with 5. How do we solve that for x? We divide by negative 3, and so we get x equals negative 5 over 3. Okay, each of these involves taking logarithm forms and either changing them to exponent or vice versa, taking exponent form and changing it to logarithm form. So let's do that. So the way that you change them is you take this number raised to that power equals that answer. So 8 to the negative 2 equals 1 over 64, and that looks like option C. This one right here is going to be the log base 5, that's the base. We would raise 5 to what power? To the second power, and it's going to be equal to what answer? To the 25. So log base 5 of 25 is equal to 2, and that's this one. Okay, oops, let's make sure we didn't skip a problem there. Okay, these now involve evaluating expressions, so this is another way of saying 3 raised to some unknown power equals 9. And of course, what do you raise 3 to get 9? You raise it to the second power. So x would have to be equal to 2 right here. Okay. This one, same thing. 5 raised to some unknown power is equal to 1 over 125, and I'm going to write 1 over 125 as 125 to the negative 1. Okay, that has to be a power of 5, and it is. It's 5 to the third power. And we still have that negative 1 there. So 5 to the x is equal to 5 to the 3 times negative 1 is negative 3. That means x is equal to negative 3. Okay, and then this one, just to double check, that equals 2. Okay, this last one, 64 to the 1/4 equals something we don't know. So let's take this, raise it to the x, and get that. 64 to the x equals, let's change 1 over 4 into 4 to the negative 1. We want this to be a power of 4, and it's 4 to the third. Okay, so then we're going to need 3x, so that's 4 to the 3x, equals 4 to the negative 1. We're going to need 3x to equal negative 1. So if we solve that for x, we would divide by 3. We would get x is equal to negative 1/3. Alright, this would probably be, let's actually finish this, and we'll continue in the next video with 7.4. So this is 7.3. We want to identify the domain and range and sketch the graph. Okay, this is a multiple choice. So first of all, the domain is going to be whatever x can equal, and we cannot have this equal to 0 or less. That can't be 0, can't be negative, because there's nothing you can raise. I mean, think about it this way. 5 to something cannot equal 0, and it can't equal a negative number either. So what would be a problem? What would cause this to be 0? X equals negative 3 would make it 0, or anything less than negative 3. So we need x to be greater than negative 3. Another way of thinking of it is add to x, go left. That means we shifted this graph to the left 3. So the domain has to be greater than negative 3. That means this one and this one are wrong. So we're down to a and d. Okay. The range is always going to be all reals. The logs cover everything. So now how do we graph this? We want the log base 5 of x, but shifted to the left 3 and up 2. So let's compare a and d. Easiest way to do this would be just to graph the log base 5 of x and then compare it. So here's what that looks like. We'll make a quick table of values here. So the easiest numbers to plug in for y would be powers of 5. Let's do 1, 5, 25, and so on. Okay, so 5 to the what power equals 1? Well, 5 to the 0 equals 1. So, whoops, sorry, I set this up incorrectly. These are supposed to be the x's. Actually, the powers of x should go right here. 1, 5, and 25. 5 to the 0 power equals 1. 5 to the first power equals 5. 5 to the second power equals 25. So this should be 1, 0. Be right here. Then we should have the point 5, 1, which would be right here. And then 25, 2. Well, that's going to be like way out here. It's going to be something that looks roughly like this. So this is kind of what the parent function looks like. We want to take that and shift it up 2, to the left 3 and up 2. So if we move this to the left 3, we took this point, that's the point 1, 0. If we move it to the left 3, it would go over to negative 2, 0. And then if we moved it up 2, it would go up to negative 2, 2. So this point, negative 2, 2, should be, or sorry, yeah, negative, that's right, negative 2, 2 should be on our graph. When we look at A, negative 2, 2, this is not negative 2, 2, that's negative 2, negative 2. Negative 2, 2, though, is on this graph right here. That is the correct graph. That's been shifted to the left 3 and up 2 versus our parent function right there. So we'll pause there, and in the next video we'll take up with section 7.4 and following.